Hello friend, in this video lecture we are going to learn the symbolic relation and separation of symbol. Symbolic relation and separation of symbol. First, averaging operator mu is defined by mu yr is equal to 1 by 2 y of r plus 1 by 2 plus y of r minus 1 by 2. Second, shift operator E is defined by EYR is equal to y of r plus 1 E square yr is equal to E of yr is equal to E of yr plus 1 is equal to y of r plus 2. Similarly, e raised to the power n yr is equal to y of r plus n. Then a relation between del and e. Del y0 is equal to y1 minus y0 is equal to ey0 minus y0, that is equal to, taking y0 common, e0 minus 1. Means this forward operator del is equal to e minus 1. That is the relation between del and shift operator E. That is 1 plus forward operator del is equal to E. E is shift operator and del is forward operator. Then some relation are first del is equal to E minus 1, then backward del is equal to 1 minus E inverse. Third, central operator, that is del is equal to e to the power 1 by 2 minus e to the power minus 1 by 2, and mu is equal to 1 by 2 into e to the power 1 by 2 plus e to the power minus 1 by 2, and that is mu square is equal to 1 plus 1 by 4 del square. And fifth, del is equal to backward del E is equal to del e to the power 1 by 2. Then we see some example of this operation, that is here. First example is, prove that mu square is equal to 1 plus 1 by 4 del square. Solution. By definition, mu yr is equal to 1 by 2 y of r plus 1 by 2 plus y of r minus 1 by 2. Then again by above some formula, this y of r plus 1 by 2 is equal to e to the power 1 by 2 yr plus e to the power minus 1 by 2 yr, and 1 by 2 e to the power 1 by 2 plus e to the power minus 1 by 2, and yr is common. Again, mu is equal to this yr and this yr cancel, then mu is equal to 1 by 2 e to the power 1 by 2 plus e to the power minus 1 by 2. Squaring both sides, we get mu square is equal to 1 by 4 e raised to the power 1 by 2 plus e to the power minus 1 by 2 whole square, and by squaring the bracket, e plus twice e to the power 1 by 2 e to the power minus 1 by 2 plus e to the power minus 1. Then 1 by 4 into bracket e plus e to the power minus 1 plus 2 means minus plus this step is cancelled, and then we write the 1 by 4 into bracket e plus e inverse minus 2 plus 4, and that is equal to 1 by 4 into bracket e minus e 1 by 2 minus e to the power minus 1 by 2 plus 4, means square of this term is this term, and we know the formula of this is del square plus 4. Formula of this is del square, and then mu square is equal to 1 by 4 del square plus 1, that is equal to 1 plus 1 by 4 del square, and this is proof, hence proof. This is the proof of this given. Okay, second, using the method of separation, of symbol, show that del raised to the power n u of x minus n is equal to ux minus n into ux minus 1 plus n into n minus 1 upon 2 ux minus 2 up to the term minus 1 raised to the power n ux minus n. Then write solution. To prove the result, first consider the right hand side, and right hand side is given as ux minus n ux minus 1 plus n into n minus 1 upon 2 ux minus 2 up to the term minus 1 raised to the power n ux minus n. And here ux minus n into e to the power minus 1 ux plus n into n minus 1 upon 2 e square ux plus minus 1 raised to the power n e to the power n ux. Then taking ux is common, and we get 1 minus n e to the power minus 1 plus n into n minus 1 upon 2 e to the power 2 minus 2 up to the term minus 1 raised to the power n e to the power minus n, and ux is common. Then this term using the expansion, and the value of this is equal to 1 minus e to the power minus 1 raised to the power n ux, means 1 minus 1 upon e raised to the power n ux. And then taking the LCM, e minus 1 upon e raised to the power n ux, and value of e minus 1 means its operator minus 1 is equal to del upon e raised to the power n ux is equal to del raised to the power n e to the power n ux, and then del raised to the power n e to the power minus n ux, and we know this is equal to del n ux minus n, means left side is equal to left hand side, and hence proof. Then next problem of this, show that e to the power x u0 plus x del u0 plus x square by 2 factorial del square u0 plus up to the term last term u0 plus u1x plus u2 x square upon 2 factorial plus like this. Then first consider e to the right hand side u0 plus x del u0 plus x square upon 2 factorial del square u0 and is equal to e to the power x plus 1 plus x del plus x square upon 2 factorial del square, and u0 is common. E to the power x, e to the power del x u0, because you know e to the power x is 1 plus x square upon 2 factorial and so on. And taking the addition of this power e to the power x plus del x u0, e to the power x common 1 plus del u0, and you know 1 plus del is equal to shift operator x e u0, and then by using the e to the power expansion of e to the power x, and then this is equal to 1 plus x e plus x square upon 2 factorial e square, like this, u0, and then multiplying that u0, that is u0 plus x e u0 plus x square upon 2 factorial e square u0, and like this, and this is the left hand side. Hence proof.